Question number 1, Part A, Roman 1. We are supposed to write 498 and 30 in words. Okay, so for this one, we just write 498,030. For Roman 2, we are supposed to express the number given in Part A, Roman 1 above, in a standard notation. Okay, so for this one, the format for a standard notation is A times 10 power n, of which the values for A should range from -9, where it is less or equal to A, and A is less or equal to +9, and n is any integer. Therefore, for this number, to put it in a standard notation, we are going to have 4.9803 times 10 power 5, and this is going to be our answer. For Roman 3, by using the listing method, we are supposed to write the lowest common multiple of 3, 10, and 15. Okay, so first we are going to start by listing the multiples of each number. So starting with 3, the multiples for this one are going to be 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. And the multiple for 10 is going to be 10, 20, 30. And the multiples for 15 are going to be 15, 30. Okay, so now from the multiples listed, we can see that the lowest common multiple equals to 30. And this is going to be our answer. For part B of the question, Roman 1, we are supposed to write in numerals 999,999,901. Okay, so for this one, in numerals, we are going to have 999,999,901, and this is going to be our answer. For Roman 2, we are supposed to determine the number of significant figures in each of the numbers 400,780 and 0.00606, and then we are supposed to approximate each number into one significant figure. Okay, so we have to remember that a significant figure is the number between 1 to 9 in any given numerals. And also we have to note that 0 will be considered as a significant figure if it is located between other numbers in a given numerals. Therefore, for this one, 478, this one has 5 significant figures. We see that 0 after 8 is not a significant figure, but zeros between 4 and 7 are significant figures. And also for this one, 0.00606, this one has 3 significant figures. We see that zeros before 6 are not significant figures, but 0 between 6 is a significant figure. Okay, so now let us approximate the numerals. For this one, 478, this can be approximated as 400,000 to one significant figure. And for this one, 0.00606 can be approximated as 0 0.006 to one significant figure. And those are going to be our answers. Question number 2, part A, Roman 1, we are supposed to write those fractions in order of their magnitude, starting with the smallest fraction. Okay, so for this one, in order to identify the order of the magnitude of the fractions, we are going first to convert the numbers into percentage by multiplying them by 100. So first we are going to take this one, 2/3 times 100, of which after solving the values, we are getting 66.7%. Our next fraction is 3/4 times 100, of which after solving this, we are getting 75%. Our next fraction is 5/8 times 100, of which equals to 62.5%. And our last fraction is 1/2. When we times with 100, the answer is going to be 50%. Okay, so from the percentage obtained above, we can see that 1/2 is the lowest number since it has lowest percentage, which is 50%. Then we can list these numbers in their order. So we are having 1/2, 5/8, 2/3, and 3/4. And this is going to be their order of magnitude required. For Roman 2, we are supposed to find the product of the fractions given in part A, Roman 1 above. Okay, so to find the product, we are going to simply multiply the fractions given. Then we are having 1/2 times 5/8 times 2/3 times 3/4. Okay, so next we are going to multiply the numerator and the denominator, and then let us write it this way. 1 times 5 times 2 times 3 over 2 times 8 times 3 times 4. Of which after multiplying the values for numerator and denominator, we are having 30/192. So simplifying this further, we are going to divide by 6 on both the numerator and the denominator. Then we are having 5/32. And this is going to be our answer. Moving on to part B of the question, we are supposed to subtract 0.02 dot of Tanzania shillings 270,000 from 36% of Tanzania shillings 50,000. Okay, so for this one, we can see that this number 2 from this decimal is the repeating decimal. Okay, so first we are going to convert the repeating decimal into fraction. So we are going to let x equals to 0.0222 and so on. Then let us call this as equation number 1. Okay, so next we are going to multiply both sides by 10 since only one number repeats. Then we are having 10x equals to 0.2222 and so on. We are going to call this as equation number 2. Then next, let us take equation number 2 minus equation number 1. 10x minus x equals to 0.2222 minus 0.0222, of which we are having 9x equals to 0.2. Okay, so now let us divide by 9 both sides. Then our equation is going to be x equals to 0.2 over 9. Okay, so now let us multiply by 10 both the numerator and the denominator. Then we are going to have x equals to 2 over 90. Therefore, 0.02 dot equals to 2 over 90. Okay, so next we are going to find 2 over 90 of 270,000. Then we are having 2 over 90 times 270,000, of which after solving the values we are having Tanzania shillings 6,000. Okay, so now let us find the 36% of 50,000. So taking 36 over 100 times 50,000, solving this we are having Tanzania shillings 18,000. Okay, so now we are going to take 18,000 minus 6,000, of which after solving the values we are having 12,000 Tanzania shillings. And this is going to be our answer. Question number 3, part A. Find the value of 500 centimeters plus 3,150 millimeters plus 3.5 meters. We are supposed to give the answer in meters. Okay, so this is the dimensions problem. First, we are going to convert all the units in meters. Okay, so we are going to first convert 500 centimeter into meters by dividing by 100. So we are going to take 500 centimeters, divide by 100. And then after solving this, we are getting 5 meters. Okay, so next we are going to convert 3,150 millimeters into meters by dividing by 1,000. So we are taking 3,150 divided by 1,000. After solving this, we are getting 3.15 meters. So after having everything in meters, we are going now to take 5 meters plus 3.15 meters plus 3.5 meters, of which after solving the values, we are having 11.65 meters. And this is going to be our answer. Part B of the question, find the number of years in which Tanzania shillings 20,000 will earn an interest of Tanzania shillings 4,800 if the interest rate is 4% per annum. Okay, so this is the simple interest rate problem. So first, let us consider the simple interest rate formula, which says I equals to PRT over 100, of which I is interest amount which we've been given from the question to be 4,800. P is the amount invested which we've been given as 20,000. R is the interest rate which we have been given as 4%. And T is the total number of years for investment. Okay, so now let us substitute the values into our formula. Then we are having 4,800 equals to 20,000 times 4 times T over 100. Okay, so now let us make t as a subject. Then our equation is going to be t equals to 4,800 times 100 over 20,000 times 4. Okay, so solving the values for the denominator and numerator, we are having 480,000 over 80,000, of which after solving the values, we are having 6. Therefore, the number of years is going to be 6 years. Question number 4, part A, Roman 1. We are supposed to write the name of the polygon ABCD represented in the following figure. So we've been given the figure there for the polygon. Okay, so for this one, since you have two pair of parallel sides and all sides are equal, then this is the rhombus. For Roman 2, from the figure given in part A Roman 1 above, we are supposed to find the values of x and y. Okay, so since we know that the opposite angles of rhombus are equal, then from the figure we can say that x equals to 2x minus 30. Okay, so next let us combine the like terms. Then our equation is going to be x minus 2x equals to negative 30. Computing this, we are having negative x equals to negative 30. Okay, so now let us divide by negative 1 both sides. Then we are having x equals to 30 degrees. And also y is going to be equals to 150 degrees. For part B of the question, we are supposed to calculate the area of the following figure if O is the center of the cycle and OABC is a square. Okay, so this one is the coordinate geometry problem. Okay, so to find the needed area, first we are going to find the sum of the areas for the square and the 3/4 of the cycle. Okay, so first we are going to start with the square. Area of a square is given by area equals to side times side. Okay, now from the figure, side equals to 7 centimeters. Then area is going to be 7 centimeters times 7 centimeters. Of which after solving the values, we are having 49 centimeters squared. Okay, so next let us find the area for the 3/4 of a cycle, which is given by the following formula, which says area equals to 3/4 pi r squared, of which pi equals to 22/7, and the r is a radius which we've been given from the question to be 7 centimeters. Okay, so now let us substitute these values into our formula. Then our equation is going to be area equals to 3/4 times 22/7 times 7 squared, of which after solving the values, we are having 115.5 centimeters squared. Okay, so now to find the area of a total figure, we are going to take 49 centimeters squared plus 115.5 centimeters squared, of which after solving the values, we are having 164.5 centimeters squared. And this is going to be our answer. Question number 5, part A. The age of the father is 3 times the age of his son. if the sum of their ages is 64 years, we are supposed to find their ages. Okay, so this is the algebra problem. First, we are going to let x be the age of son. Then the age of a father is going to be 3x. Okay, so now we are going to take the sum of the ages, which is going to be x plus 3x, which we've been given from the question to be 64. Okay, so solving the values from our left-hand side, we are having 4x equals to 64. Okay, so now to find the value of x, we are going to divide by 4 both sides. Then after doing that, our equation is going to be x equals to 16. Therefore, the age of a son equals to 16 years. Okay, so now to find the age of a father, we are going to take 3 times 16, of which after solving the values, we are having 48 years. And those are our answers. Part B of the question, solve the quadratic equation x squared plus 7x plus 12 equals to 0 by using the factorization method. Okay, so for this one, first we are going to take the product of the coefficient of x squared and the constant term, which is 1 times 12, which equals to 12. And from this product, we are going to find the two factors that can be added to give the coefficient of a middle term, that is 7, in order to split the middle term. Okay, so those factors are 3 and 4. Okay, so now 7x can be splitted as 3x plus 4x. Then our equation is going to be x squared plus 3x plus 4x plus 12 equals to 0. Okay, so now let us separate the expression with the brackets. Then we are having, in brackets, x squared plus 3x plus, in brackets, 4x plus 12 equals to 0. Okay, so next we are going to factor out x from the first expression, and then we are going to factor out 4 from the second expression. Then our expression is going to be x, in brackets, x plus 3 plus 4, in brackets, x plus 3 equals to 0. Okay, so next we are going to factor out x plus 3 from both expressions. Then we are having, in brackets, x plus 3, in brackets, x plus 4 equals to 0. Then we say x plus 3 equals to 0, or x plus 4 equals to 0. Solving this, we are having x equals to negative 3, or x equals to negative 4. And those are going to be our answers. Question number 6, part A. A line passes through the points A with 6,4 and B with 12,6. For this one, we are supposed to find the slope and the equation of the line. Okay, so this is the coordinate geometry problem. Okay, so first we are going to find the slope of a line. Let us recall the formula for a slope of a line, which says slope equals to y2 minus y1 over x2 minus x1. Okay, so from the information from our question, x1 is 6, y1 is 4, x2 is 12, and y2 is 6. Okay, so now let us substitute these values into our equation. We are having slope equals to 6 minus 4 over 12 minus 6, of which, solving this, we are having 2 over 6, which, solving further, we are getting 1 over 3. Okay, so now to find the equation of the line, let us recall the general formula, which says y equals to m in brackets x minus x1 plus y1. Okay, so now let us substitute their values. Our equation is going to be y equals to 1 over 3 in brackets x minus 6 plus 4. Okay, so next let us open the brackets by multiplying by 1 over 3. Then our equation is going to be y equals to 1 over 3x minus 2 plus 4. Okay, so now let us combine the like terms. We are having y equals to 1 over 3x plus 2. And this is going to be the equation of the line. Part B of the question, Roman 1, a translation takes the origin to -3, -4. Without drawing, we are supposed to find where it takes q 1, -2. Okay, so this is the transformation problem. Let us consider the following relation of a transformation, which says image equals to translation factor plus point given, of which this becomes x image y image equals to a b plus x y. Now x image y image is given as -3, -4. Then x y equals to 0, 0. Okay, so now let us find the translation factor by substituting values into our equation. We are going to have -3, -4 equals to a b plus 0, 0. Then this becomes a b equals to -3, -4. Okay, so now from the translation factor, we are going to find an image for the point Q, that is x image y image equals to -3, -4 plus 1, -2. Okay, so now let us combine the numbers. We are having -3 plus 1, -4 plus -2, of which, solving this, we are having -2, -6. Therefore, the translation will take point Q to -2, -6. For Roman 2, we are supposed to find the images of the point A, -5, 2, and B, 4, -7 after reflection in the y-axis. Okay, so again, this is the transformation problem. We have to remember that for the reflection, image is located the same distance from the line of the reflection as the original point, but opposite sides. And also, the line joining the original point and an image is perpendicular to the line of the reflection. Okay, so now we are going to draw the X and Y axis and then we are going to label them. Starting with point A with -5, 2, we locate point A, -5, 2. Then we draw perpendicular line from point A crossing Y axis. Then we are going to measure the distance from point A to Y axis. Now using the measured distance, we can locate the image of point A. Therefore, A image is 5, 2. Next, we locate point B, 4, -7. Then we draw perpendicular line from point B crossing Y axis. Then we measure the distance from point B to Y axis. Now, using the measured distance, we locate the image of the point B. Therefore, B image is -4, -7. Question number 7, part A. Find the value of X in the equation. So we've been given the equation there. Okay, so this is the exponential problem. So first, we are going to start by expressing 1/3 and 81 in exponential of base 3. Then our equation is going to be, in brackets, 3 power -1 power under root x equals to, in brackets, 3 power 4 power -1. Okay, so next, let us multiply the exponents. Then our equation is going to be 3 power negative under root x equals to 3 power -4. Okay, so now, since the bases are the same, we are going to compare the exponents. Then our equation is going to be negative under root x equals to -4. Next, let us square both sides in order to eliminate the square root. Then our equation is going to be, in brackets, negative under root x squared equals to, in brackets, -4 squared. Solving this, we are getting under root x squared equals to 16. Solving further, we are getting x equals to 16. And this is going to be our answer. Part B of the question, if log x over 5 base 10 equals to log 2 over x base 10 plus 1, we are supposed to find the value of x. Okay, so this is the logarithm problem. We have to recall that log 10 base 10 equals to 1. Okay, so now let us substitute this 1 with log 10 base 10. Then our equation is going to be log x over 5 base 10 equals to log 2 over x base 10 plus log 10 base 10. Okay, so now let us apply the product rule of logarithm for the right hand side. Then our equation is going to be log x over 5 base 10 equals to log in brackets 2 over x times 10 base 10. Solving this, we are having log x over 5 base 10 equals to log 20 over x base 10. Okay, so since we have the common bases for both sides, then we are going to equate the numbers. Then our equation is going to be x over 5 equals to 20 over x. Okay, so now we are going to cross multiply these values. Our equation is going to be x squared equals to 100. Applying square root both sides, then our equation is going to be under root x squared equals to under root 100. Simplifying this further, we are having x equals to 10. And this is going to be our answer. Question number 8, part A. In the following figure, Px and Qy are perpendicular to PQ, and Px equals to Qy. We are supposed to show that the two triangles XPA and YQA are congruent. Okay, so from the figure, angle XPA equals to angle YQA because both have 90 degrees. And also, angle PAX equals to angle QXY because these are opposite angles. And also, side PX equals to side QY because of the information given from the question. Okay, so now since two angles and one side from both triangles are equal, then triangle XPA is congruent to triangle YQA by angle side. For part B, triangles ABC and DEF are similar. We are supposed to find the size of the angles labeled X, Y, Z, and W. Okay, so we have to recall that the corresponding angles from similar triangles are equal. Then we say angle ABC equals to angle DEF. Angle ACB equals to angle DFE. Angle BAC equals to angle EDF. Okay, so with that information, now we have W equals to 90 degrees, Y equals to 60 degrees, and Z equals to X. But we know that the sum of the angles in a triangle are going to be 180 degrees. Then we say W plus Y plus Z equals to 180 degrees. Okay, so now let us substitute the values in order to find the value of Z. Then our equation is going to be 90 plus 60 plus Z equals to 180. Let us now combine the like terms. We are having Z equals to 180 minus 90 minus 60, of which after solving the values, we are getting Z equals to 30. And also, we say that X equals to 30 degrees. And those are going to be our answers. Question number 9, part A. In the following figure, PQ equals to 17 centimeters, QS equals to 15 centimeters, RS equals to 6 centimeters, and PR equals to X. We are supposed to find the value of X. Okay, so to find the value of X, let us first find the side PS from triangle PQS. Now for this one, we are going to use the Pythagoras theorem, which says PS squared plus QS squared equals to PQ squared. From the figure, QS is 15, PQ is 17. Then let us substitute these values. Our equation is going to be PS squared plus 15 squared equals to 17 squared. Okay, so next let us combine the like terms. Our equation is going to be PS squared equals to 17 squared minus 15 squared. Solving this, we are having PS squared equals to 64, of which applying the square root both sides, our equation is going to be under root PS squared equals to under root 64. Solving this, we are having PS equals to 8. Okay, so now from the triangle PSR, let us apply the Pythagoras theorem. Then we are having 8 squared plus 6 squared equals to X squared. Solving this, we are going to have 100 equals to X squared. Computing this, we are going to get X equals to 10. Therefore, we say X equals to 10 centimeters. Part B of the question, the angle of elevation of the top of the vertical building from a point on the ground is 25 degrees. The point on the ground is 80 meters away from the base of the building. By sketching a diagram, we are supposed to represent this information, and also we are supposed to calculate the height of the building. And also we are supposed to write the answer correctly to one decimal place. Okay, so let us sketch our problem. So first we are going to draw the ground. And next we are going to draw the line representing the building. And then we are going to draw this line for the elevation. So here is 25 degrees, and this is our elevation angle. And here is 80 meters. Okay, so next we are going to let y be the height of the building. Then using the tangent formula, which says tan theta equals to opposite side, in our case here is height of the building, over hypotenuse side, in our case is going to be the ground distance. Okay, so from the information given, the ground distance is 80 meters and the theta is 25 degrees. Okay, so now let us substitute these values into our formula. Then we are going to have tan 25 degrees equals to y over 80. Okay, so next we are going to make y as a subject of the formula by multiplying both sides by 80. Then our equation is going to be y equals to 80 times tan 25. Okay, so now reading from the table, tan 25 equals to 0.4663. Then our equation is going to be y equals to 80 times 0.4663. 37.463, of which after solving the values we are having 37.304. Okay, so rounding this into one decimal place, we are having the height of the building to be 37.3 meters. And this is going to be our answer. Question number 10, part A. In a class of 30 students, 17 participate in English debate and 12 participate in both English debate and mathematics club. If every student is required to participate at least one of these two events, we are supposed to find the number of students who participate in for Roman 1 English debate only. Okay, so now let us extract the information which you've been given from the question. So students who participate both in English debate and mathematics club are 12. Then to get a number of students who participate in English debates only, we are going to take the number of students who participate in English minus the number of students who participate in both English debate and mathematics. So we are going to take 17 minus 12, which after solving the values, we are getting 5. And that is going to be our answer. For Roman 2, we are supposed to find the number of students who participate in mathematics club only. Okay, so for this one, we are going to let X be student in mathematics club only, then student in math only, plus student in English only, plus those who take both, equals to total number of students. Then substituting the values, our equation is going to be X plus 5 plus 12 equals to 30. Okay, so next let us combine the constant terms. Then our equation is going to be X equals to 30 minus 12 minus 5, of which after solving the values we are getting 13. So number of students who participate in mathematics club only are going to be 13 students. Part B of the question, the age of students selected of participate in a debate competition were recorded as follows. So we've been given several information there. For Roman 1, we are supposed to prepare a frequency distribution table showing the ages of students and their corresponding frequencies. Okay, so we have to remember that a frequency table is a table of the data with their corresponding frequencies. Okay, so now we are going to sketch a table which is going to have student and also their corresponding frequencies. Okay, so our table is going to start with the lowest data. So here we have 13, here is 14, here is 15, here is 16, here is 17, and here is 18. Okay, so next, to complete the table, we are going to fill the frequency column by counting how many times does a specific data appear. Okay, so counting number of students with 13 years, then the total number is going to be 2. And then for the next, the number is 3. The next, the number is 5. Next is 6. Next is 3. And the last one is 1. And this is going to be our frequency table requested. For Roman 2, we are supposed to draw a frequency polygon representing the given information. Okay, so we have to remember that frequency polygon is the line graph drawn using the data against their frequencies. Okay, so for this one, first we are going to draw X and Y axis. Then next we are going to label X axis. So we have 12, 13, 14, 15, 16, 17, 18, and 19. Okay, so next we are going to label the y-axis. So here is 1, here is 2, here is 3, here is 4, here is 5, 6, and 7. Okay, so next we are going to mark the points. Then finally, we are going to join the points using a straight line. And this is going to be our final sketch.